Lesson 3.8. Use inverse matrices to solve linear systems. We can use matrices to solve linear systems in ways other than Cramer's rule. But to do that, you need to know about an inverse matrix. To find an inverse matrix, you need to know about the identity matrix. The identity matrix is a matrix that, when multiplied with any matrix of the same dimension, it equals the original matrix. It's the matrix equivalent of 1. And here's the pattern. The downward diagonals are 1. Downward diagonals are 1. And everything else is a 0. And they are square. They're there, so when we multiply by the identity, I here stands for identity matrix. So matrix A times the identity equals A. Or the identity matrix times matrix A equals matrix A. So it's like 1. We have added, subtracted, and multiplied matrices, but you cannot divide by a matrix. So we multiply by the inverse instead, kind of like you would multiply x times the inverse of x, which is 1 over x, to get 1. So A times the inverse of A equals identity matrix. Just like x times inverse of x, which is 1 over x, equals 1. So how to find the inverse? We are only doing 2 by 2 matrices. Finding the inverse of larger matrices are a little bit more difficult, and we'll do that in pre-calculus if you want to learn how. This is just a formula. You need to memorize it. If matrix A is A, B, C, D, the inverse of matrix A is 1 divided by the determinant times what I call the mixed-up matrix. Notice the A and the D have traded places, and the B and the C have changed signs. So let's find the inverse of this matrix. It's 1 over the determinant times the mixed up matrix. The 1 and the 4 have traded places. The 2 and the 3 changed signs. We'll find the determinant of this first. So it's the downward diagonal minus the upward diagonal. So it's 1 times 4 minus 3 times 2. So that gives us 4 minus 6, which is negative 2. And so it's negative 1/2 times the matrix. That's scalar multiplication. We just distribute that negative 1/2 to everything. So negative 1/2 times 4 is negative 2. Negative 1/2 times negative 2 is 1. Negative 1/2 times negative 3 is 3/2. Negative 1/2 times 1 is negative 1/2. And that's the inverse. Alright, now let's find the inverse of this matrix. It's 1 over the determinant times the mixed up matrix. Notice the 0 and the negative 2 have traded places. The 4 became negative and the negative 1 became positive. So these two change their sign. Find your determinant. So it's the downward diagonal minus the upward. Negative 2 times 0 minus 4 times negative 1. That gives you 1 over 4, which you will then distribute to the matrix. So you have 1 over 4 times 0. You have 1 over 4 times 1. 1 over 4 times negative 4. And 1 over 4 times negative 2. Which gives you that. We can check that two matrices are inverses by multiplying them together. So here's the matrix and its inverse from the last problem. if I multiply these together, so it's a row and a column, so it's 2 times 0 and negative 1 times 1. First row, second column, negative 2 times the fourth, plus negative 1 times the negative half. Second row, first column, 4 times 0, and 0 times negative 1. And second row, second column, will be 4 times 1/4, plus 0 times negative 2. Simplify each of those, and you get 1, 0, 0, 1, which is the identity matrix. Alright, so now we want to use matrices to solve a system. So if A, B, and X are matrices, and we have the equation A times X equals B, usually you'd solve for X by dividing by A. But we can't divide by A, so we'll multiply by the inverse. Remember, matrix multiplication is important, the order is important. So if I put the inverse of A in the front, so it multiplies with A, it'll have to go in the front on the other side, because the order of matrix multiplication is important. Inverse times the original, it gives you I, and I times X gives you just X. And that is how we would solve for matrix X. So let's solve this matrix equation. AX equals B. A matrix A is this negative 3, 4, 5, and negative 7. Matrix B is the 3, 8, 2, and negative 2. First thing we need to do is find the inverse of matrix A. So here's the inverse. Remember, it's 1 over the determinant times the mixed up matrix. These two traded places. These two change signs. Find your determinant. It's negative 3 times negative 7 minus 5 times 4. Work that out and you should get 1. It's 21 minus 20, so you get 1. So 1 times the matrix, it's just the matrix. So that's our inverse. On to the next slide. Now to solve this equation, we'll multiply both sides by the inverse matrix. The inverse of A and times A cancels out. So on the left, we're left with just the X. So our X equals the inverse of A times B. So here's the inverse of matrix A, here's matrix B. Multiply those together. So we're going to pick first row, first column. You get negative 7 times 3. It's negative 4 times 2. And then we can do first row, second column. Negative 7 times 8 plus negative 4 times negative 2. And then we can do second row, first column. Negative 5 times 3 plus negative 3 times 2. And then we can do second row, second column. Negative 5 times 8 and negative 3 times negative 2. Simplify each of those elements, and that's our answer for matrix X. Here's one where we have a system of linear equations. So before we can use matrices to solve it, we have to write it out as a matrix equation. Be in the form A times X equals B. So matrix A is the coefficients. Notice these are the coefficients from up here. And then we have our variables, x, y, equals the constants. In order to solve for the variables, we need to find the inverse of matrix A. So we're finding the inverse of our coefficient matrix. So it's 1 over the determinant, which is 2 times negative 3, minus 1 times 1. So that's negative 6 minus 1 gives us the negative 7. Then we have the mixed up matrix, the negative 3 and the 2 traded places, and the 1's got the opposite sign. So I'm going to multiply the front of both sides by that inverse. The left side cancels out, this part cancels out, leaving just the x. So here I have my inverse and the constants, which was matrix B. Multiply these together. So if I do first row and our only column, get negative 3 times negative 13 plus negative 1 times 11. Then I can do second row only column. You get negative 1 times negative 13 plus 2 times 11. Simplify each of those, become 28 and 35. Then we can multiply it by the negative 1 over 7. Negative 1/7 times 28 is negative 4. Negative 1/7 times 35 is negative 5. And remember, that equals this xy. So this is x, this is y. Therefore, x is negative 4, y is negative 5, and that's the solution to our system. And here's your homework. Enjoy it.